Now let us do question 7. Let A, B, C, and D be 4 sets. We need to prove that A minus B is a subset of C minus D. If and only if we have two things. The first one is A is a subset of B union C. And the second thing, A intersects D is a subset of B. Okay, this is a biconditional statement. We need to prove two directions. So the forward direction is, suppose that we have the left hand side. This is our hypothesis. And we need to show the right hand side. We need to show A is a subset of B union C and A intersect D is a subset of B. So let's prove this part first. We first show that A is a subset of B union D, B union C. So by definition of subset, this set is a subset of the other set if any element in A must be an element in B union C. So now let X is an element of A. We want to show X is an element of B union C. Okay, remember that we have this hypothesis. Okay, so case 1. X is an element of B. Or K2, X is not an element of B. I want to use this hypothesis. Therefore, this means that X in A but not in B, right? So the case is not in B we have here. So to complete all the possibilities we have, I need to show that it's also true for case 1. X in B is or X not in B. Okay, let's do case 1. Suppose X in B, then X must be an element of B union with whatever we like. So when choose whatever we like is C. So X in B implies X in B union C. This implies in B union C. So now for arbitrary X in A, X must be in B union C. Therefore, this is true. Therefore, A is a subset of B union C. So case 1 is easy. K2, X not in B. What does this mean? We have X in A and X not in B. So we have X in A and X is not in B. By definition of set different, we know that X in must be in A minus B. Okay, so now X in A minus B. A minus B is a subset of C minus D. We should highlight this. This hypothesis we know. So since we have this part, okay. So because we have A minus B is a subset of C minus D, X must be an element of C minus D. Does this make sense? So X in here, but here is a subset of there. So X must be in C minus D. Okay. So what do we need to show? We want to show this. X is in B union C, right? So here X in C minus D. So in particular, we have X in C and X not in D, right? So in particular, X in C. And therefore, X in C union B, which what we need to show, right? Therefore, we start from X in A. And in both cases, we show that X in B union C. We start from X in A, and we show the X in C union B. So they are true for case 1 and case 2. Same. Case 1. And 2 for both cases. So in this case, we also have A is a subset of B union C. Okay. So we have done the first part. So we have done this first part. We prove the still in the first part, but because this is the first thing we show. Yeah, we first show this one. Let's do the second one. So we need to show the other container map. We will show it. We will show that. Actually, this one should work the same, right? This is a set. This set is a subset of the other one. So we start from the small set first. Let X be an element of A intersect B. We need to show X is an element of B. Okay. So X in A intersect D. By definition, X is in A and X in D. And X in D. Okay, what can we use now? We have, remember that we have this yellows, this the hypothesis we have A minus B is subset of C minus D. Remember we have this. Okay, just maybe we just recall that we have this part. We have this part. And we need to show that X is an element of B. We need to show X is an element of B. Now, let's do it by contradiction. What if X is not in an element of in B? So, if suppose by contradiction X is not an element of B, then what? We then have X in A, what we just say here, X not in B, and Therefore, we have x in A minus B. By definition, right? X in A and x not in B. Therefore, x must be in A minus B. However, A minus B is a subset of C minus D. A minus B is a subset of C minus D. We have x is an element of C minus D. Does that make sense here? X is an element in this set. But this set is a subset of this set. Therefore, x must be an element of C minus D. Okay. What does that mean? By definition, x is an element of C and x is not an element in D, right? So now, what can be wrong? We suppose a contradiction this one, right? And we know that it's not true because we need to show x in B. So what can be wrong here? X in C and x not in D. But remember that, let me write here. We know that x in A intersect D and x in D. We know this here. But here we have x not in D. You see the contradiction, right? X cannot be in D and not in D at the same time. So this is contradiction. This contradicts to the fact that x is an element of D, as we know before. Thus, our assumption is wrong. X must be an element in B, which what we need to show. And therefore, this set is a subset of B. And this is the first pass or the first direction of this biconditional statement. So we prove this part and the other one. Now we need to go from here to there. Okay, suppose we have this part, suppose we have the right hand side. So the other direction. Now suppose that we need to show here A minus B is subset of C minus D. Okay, so now you know how to show a set is a subset of another one, right? Pick an element in here, show it's an element in there. So let x be an element of A minus B. We need to show x is an element of C minus D. Okay. So now let's start from here. X is an element of A minus B. What does this mean? Definition x in A minus B means x in A and x not in B. Okay. X in A and x not in B. So x in A. But our hypothesis A is subset of B union C. Right? Since A is a subset of B union C and x in A and x is an element of A, we must have x is an element of B union C. Does that make sense? X in here But here is subset of B union C. Therefore, X must be in B union C. Okay, now look, X in B union C, but X not in B. Therefore, X must in C. By just definition of union. Now, since X in B union C, but we and X not in B, we must have X in C. Does that make sense? X in the union, but not in this part. Therefore, X must be in the other part, right? Just the union of B union C is just a set of own point, the own elements to X. X either X in B or, so this is logical or, either in here, in there, or maybe in both. X in C. X not in B, therefore X must be in C. Okay, so we already show this part, X is an element of C. Now, we just need to show that X is not an element of D. Okay, what if X in D? Now, we just need to show X is not an element of D, right? Because we already have X in C, and we just need to show X not in D. Therefore, X is in C minus D, right? Suppose not. Is in element of D. What can be wrong? X in element of D. Now we have X in A, X in D. Suppose X is an element of D. Since X is also in A, we must have X is in the union, in the intersection, I'm sorry. I should highlight this, X in A and X in D. Therefore, X in A intersect D. Okay. But A intersect D is a subset of B, right? But since we have A intersect D is a subset of B, we must have X is an element of B. Does that make sense? X in here, A intersect D. But this set is subset of B, therefore X must be in B. So let me highlight this. We have too many colors here. X is in B. But we know that X is not in B. This is where it's wrong. So our assumption here, what we suppose is wrong, which contradict to the fact that X is not in B. And therefore, our assumption is wrong. This is wrong, right? Therefore, X not in D. And X not in D, then this is exactly what we need to show. Okay, summarize, we have here X in C and X not in D. Now, we have shown that X in C and X is not in D. So this means X in C minus D. What is exactly what we want to show. And therefore, we start from here. We show that this is an element in there. Therefore, we prove this part. Truth, we have this. And this is the other direction, the backward direction of the biconditional statement. And yes, we're done. So here's the proof of this exercise. So we go from here and we reach there. And therefore we're done.